In this lesson, we're going to learn about properties of rhombuses, rectangles, and squares. And the objective is to define and classify special types of parallelograms, such as rhombuses, rectangles, and squares, and to use the properties of the diagonals of rhombuses and rectangles in particular to work in problems. So let's look at our definitions and theorems on the left. The first definition is for a rhombus. So a rhombus is a parallelogram with four congruent sides. So it's important to remember it has all of the properties of a parallelogram that we've already learned, plus it has four congruent sides. The next one is for a rectangle. A rectangle is a parallelogram with four right angles. Once again, it has all of the properties of a parallelogram, plus it has four right angles. And finally, the definition for a square. Square is a parallelogram with four congruent sides and four right angles. So that's the markings on the diagram, the four right angles and the four congruent sides. So from the diagram of special parallelograms there, we can see that with the Venn diagram, if you looked at the properties of rhombuses and rectangles and combine them, overlap that, then you're going to have the properties of a square. So another way to show that a quadrilateral is a square is to show that it is both a rhombus and a rectangle, because it has the properties of both. The first theorem in this lesson says that if a parallelogram is a rhombus, then its diagonals are perpendicular. The next theorem says that if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So those are two additional properties of a rhombus. The last theorem says that if a parallelogram is a rectangle, then its diagonals are congruent. So that is an additional property of a rectangle. So let's use these over in the exercises. In problem 1, we're classifying special parallelograms, and it asked, is parallelogram FGHJ a rhombus, a rectangle, or a square? And explain your answer. So let's look and see what it gave us. It gave us one right angle, and it gave us two consecutive sides that are congruent. So how can we use that information? We know that it is a parallelogram. So using the properties that we know for a parallelogram, we know that consecutive angles are supplementary. So that means if angle F is a right angle, then angle J has to be a right angle, and you can work your way around. If J is a right angle, H has to be a right angle, and if H is, then G is also. Okay? So there we know it has four right angles. We also know from the properties of parallelogram that the opposite sides are congruent. So FJ has to be congruent to its opposite side, which is GH, and JH has to be congruent to its opposite side, which is FG. So we now have four right angles and four congruent sides. So we know that it's a square because of the four right angles by the same side interior. And then we know that it has four congruent sides, since the opposite sides are congruent. It's not just a square, however. Because it's a square, so because it is a square, it's also what? It's also a rhombus, and a rectangle. So the answer to the question is that it's all three. It's a square, it's a rhombus, and it's a rectangle. In problem 2, it asks what are the measures of the numbered angles in rhombus ABCD. Since we know that a rhombus is a parallelogram with four congruent sides by definition, let's use some properties of a parallelogram on this. So the first thing you should see is that the measure angle 1 and the 100-degree angle are opposite angles. So they have to be congruent by definition or by the property of parallelogram. So the measure angle 1 is equal to the measure of angle D, which is 100 degrees. So let's look at that, at the other property here. Let's look at the 100-degree angle with angle DAB. So angle DAB is consecutive to the 100-degree angle. So that means that the measure of angle DAB plus 100 has to equal 180 because they're supplementary. So subtract the 100 from both sides. The measure of angle DAB is going to be 80. And since that's 80-degree angle, and one of the properties of the rhombus that we went over was that a diagonal of a rhombus bisects opposite angles. We know that the measure of angle 2 has to be equal to the measure of angle 3 because that angle is bisected in the rhombus. So if that's bisected, then each of those angles are going to be 40. It's going to be half of the 80-degree angle. In the last problem, we're finding diagonal lengths, and it's in a rectangle. In rectangle MNOP, it tells us that PN, which is this diagonal, PN is equal to 7x minus 8. And MO, which is the other diagonal, is equal to 4x plus 10. So what is the length of PN? So if we look at these, the properties of a rectangle, one of the properties says that the diagonals of a rectangle are congruent. So we know that the length of PN has got to be equal to the length of MO. Substitute the values in. 7x minus 8 is equal to 4x plus 10. Solve this. Subtract the 4x from both sides. Add the 8 to both sides. And x is equal to 6. Now you're not finished with the problem because the problem is asking what's the length of PN. So plug that back in because PN is 7x minus 8. So that's 7 times 6 minus 8. 42 minus 8 is going to be 34.